Well, pig bums. Did I just waste 3 weeks of my life? I mean, that would be on brand for me. Hello Internet, my name is Quinn and this is Blondihacks. Today I'm going to make this lovely thing. This is the crankshaft for a 1/4 horsepower steam engine designed in 1895, and I happen to be building such an engine, so I need one of these. So let's make one. Here's what the kit comes with: 2 pieces of cold rolled steel and these cast iron discs that form the legs of the crankshaft, if you will. So this is a composite crankshaft. It's made of 5 pieces that are intended to be press fitted together. Now, maybe that's fine, but I actually don't love that strategy, and here's why. The crank pins are supposed to be pressed into holes here, which would leave a very thin web of cast iron on the outside rim there. And cast iron is basically the concrete of metals. It's very, very strong in compression, very poor in tension. So I don't love the idea of doing press fits here on these cast iron discs. And I also think it's going to be difficult to keep everything straight doing that. I don't personally have a great history of keeping things straight when press fitting, so I'm going to do a different strategy here. I'm going to assemble all these parts with very close slip fits that are pinned rather than press fit. And to guarantee everything stays aligned and concentric, I'm going to do a slightly different construction strategy here that you'll see as I go along. But I need to start by cutting the tabs here, the sprues, off of these castings. So I'll clean those off of there, and then I'll finish that up with the Dremel to get things, mostly round, and also to get all of that casting scale off the outside. I've really found it helps a lot to ease the machining if you grind the scale off the outsides of these castings first. There's often like really glass hard sections in this scale. Now with any casting that spins, you want to try and get the cast details that will remain unmachined as concentric as possible in your setup. Otherwise the part will look like it's wobbling when it runs, even if it's running true. So that's not really easy to do here because I don't have a full circle on this inner rim. So I'm just going to have to indicate on the OD and hope that it's going to be okay when we're done. So I'm going to start by gripping that boss there in the 4-jaw chuck here, and I'm going to machine the back face here of each of these discs. I'm going to dial this in, as I said, using the OD there, and hope that it's going to be sufficiently concentric. And that looks like it's running okay, but it's weeble wobbling a little bit there, so I brought in the Jacob's chuck and retracted the jaws to give me a large flat surface, and then I just loosened the 4-jaw, pushed the casting up against the Jacob's chuck, tighten it again, and that trues it up nicely there. So it's running reasonably true and square there. So now I can start facing this off. I did not grind the scale off of this face because I figure, well, it's a nice rigid setup. I can just cut under the scale in one pass. Not a big deal. And away we go. And yeah, you hear that thunking and clunking noise? Yeah, that's the scale. And oh boy, look at that. Immediately burned the tip off of this high-speed steel tool. That's what that scale does. It's nasty stuff. I always regret it when I don't grind it off. So I hit it with the flap wheel on an angle grinder, reground my tool, and now that's cutting just beautifully. The difference is night and day. Once you don't have to cut through that scale and you're just cutting cast iron, it's so much better. So strong recommend for that approach. With that flat and cleaned up, I'm going to punch a hole through the center of this now, starting with the center drill and then a pilot drill. And I'm going to bore this out to the final size for the crankshaft that goes through the center. Now, the original design calls for 2 stub crankshafts, one on each crank disc, but I'm going to do this as one large crankshaft that runs all the way through, that's going to remain throughout the construction, and then the center section will be removed at the last moment, and that's going to ensure that everything stays concentric as we do this. So this dimension here is very critical. This has to be as close to a press fit without actually being a press fit as I can possibly get it. So I'm talking about like a 3 or 4/10 slip fit. Very, very close. So I really took my time on this dimension, because if this is a little bit too sloppy, then these crank discs might tilt or otherwise not be secure on the center crankshaft there. That dimension looks very, very good. Very happy with that. I'm just a couple of tenths over the crankshaft that's going to go in there. So that should be perfect. And I wasn't super crazy about the finish that I got, so I just got out the cheater paper and shined that up a little bit. The other thing I should note here is all of the dimensions on these I'm leaving at the high end of their tolerances. So once all of the pieces are mocked up on the center crankshaft before it's cut apart, I can then do finishing cuts on everything to true it up if needed before cutting it into an actual crankshaft. So there's the first of the 2 crank discs finished to that stage. So I did them both that way. But before going any further, I'm going to do the crank pin hole next. And this might seem unconventional, but this will make sense in a moment. So I'm using a center finder there to mark the rough center of the cast area there where the pin is supposed to be. This is just aesthetic, but I want to try and get it centered. Then I transferred that line down the sides of both crank discs. Now the material that they supplied for the crankshaft stubs is actually very precise. It's within a few tenths of the same diameter all the way down. So this is probably high tolerance stock that they're supplying. So it's nice stuff. And I'm going to use it as a mandrel here for this setup. So I set that up vertically in a V block here, and I'm going to put the 2 crank discs on there. And then this will allow me to align those marks so that I know the bosses are centered above and below. Now I can clamp them together and I'll be able to drill those bosses straight through. I'm centering it up on the mill just using a collet there. So I tighten the collet on that mandrel, and then I can zero the DRO right there and I know it's centered. So then I set up a machinist jack underneath and some clamps above, release the spindle, and now I should be set up to drill that hole. However, there's a flaw in this setup. I don't have a way of rotating that crank disc in place in order to get it aligned on the x-axis of the mill so I can get the translation right so that the crank pin lands in the correct spot. Plan B, I set it up in the vise, and by clamping the V-block in the vise, this allows me to hold the mandrel still, but still rotate the discs independently and line up the center drill there on my scribe line. So that solved that problem, but now I have 2 new problems. There's no good way to clamp this disc in position once I've aligned it, and this setup is too tall in the mill. I don't have room for the reamer that's going to be needed for the final step. So plan C, I've got a scrap of aluminum here that happens to have a little step on it. I found it in the scrap bin, and I'm chucking this up in the forejaw, just roughly centering it. Doesn't have to be perfect. And I'm facing this off on the bottom, and then I'm going to be putting a hole through the center. So facing the bottom ensures that the hole that I put in it is perfectly square to the bottom surface of this when I'm done. So it doesn't really matter how well it was clamped in the forejaw because I've faced it, and now I'm going to put a hole in it in the same setup. So now if I center drill, pilot drill, drill, and bore this to a close slip fit on that mandrel, I'm going to have a thing that can sit flat on the mill table and hold that mandrel extremely vertically because all these features were done in the same setup on the lathe. There's the mandrel once again, and oh boy, that is a lovely, lovely fit. Can just barely slide that in there. That moment just never gets old. This scrap has these little shoulders on it that work with my low profile clamps here to hold this down without interfering with the work above it. And that was just luck. If I hadn't had that piece of scrap with the shoulders, then I might have just bolted this through down to the table, something like that, but this worked. So then I can use that mandrel once again in the mill spindle and align it so that it slides down in that hole, zero the DRO right there, and now I can put my mandrel down in the hole there. It's being held perfectly vertical by that block. Slide the discs down over there, and once again the discs can rotate freely, and now I'm in a position where I can clamp them down. Now I need some little tiny machinist jacks, so in the scrap bin I found this, I think it's like a stud that's supposed to be pressed in with threads on it and some threaded inserts. I don't know, random hardware made tiny little machinist jacks. This is why I never throw out hardware. And with this setup here, I was then able to clamp it down in position above and below with the rotation correct, and the spindle is centered on the mandrel there, so then I was just able to use the x-axis on the mill to move over the exact amount for the crank pin distance, which is critical because that sets the crank throw of the engine, and then I was able to center drill, drill, and ream this out. So a bit of a fussy setup, but it was worth it to get all of that just right. I showed you all the steps there so that you could see the evolution of a setup, because the first thing you try often doesn't work. So you can see how I learned a little something from each version of a setup that I tried for this. You could also do this with offset turning on the lathe, but I don't have enough throw on my four-jaw chuck to do that, so I'd have to use the faceplate, and I wanted to do both pieces together like this so that I guarantee that those 2 crank pins are in exactly the same place on each disc. So again, just trying to really make sure everything ends up concentric and running true when I'm done here. Now the reason I did that now is because it's time to go back over to the lathe, and I might need a drive dog on these parts for the next operation, and so that crank pin hole can act as a drive dog if I need it. So next I have a piece of scrap here, and I'm going to make a mandrel for the rest of the operations on these discs. So I need enough stick out for both discs and a nut on the end. Now this scrap has an old center in it that is bound to have run out in it because I'm chucking in a 3-jaw here, so it's not going to land in the same place. So to recut a center, you can see that I'm applying a little bit of lateral pressure with the tool post on the Jacobs chuck there. and that forces the center drill to cut only on one side so that it doesn't follow the old hole and just enlarge the hole while not correcting the runout. It's a trick I learned from Adam Booth. And now I can put the tailstock center in there, and I can check by feel to see if it's vibrating or shaking or moving, and it's not, so my new center is, in fact, on center. I'm turning down this entire mandrel to be, once again, a close fit on the center of these crank discs. This mandrel is going to hold these discs in place and allow me to finish the rest of the features on these crank discs while maintaining that center bore of the discs as the reference for all subsequent features. So that's real close, but a little too big, and I don't want to chance taking another cut, so I'll finish that off with some cheater paper here. And that is a really good fit. I can just barely slide those discs on there, which is the way I want it to be. Looking good. Now I need some threads on the end there. So I'll mark where the discs are going to land, and I'll cut the threads a little bit deeper than that to make sure that I get some clamping action here. So I'll just turn that down to the OD of the thread that I'm going to use. You'll note that I've left a shoulder on the back of this mandrel in front of the chuck jaws. It's tempting to use the chuck jaws themselves as the backstop for a mandrel like this, but don't do it, because then when you tighten the nut, it's just going to pull the stock out of the jaws, and the stock isn't going to get tight on the mandrel. So you always want to have a shoulder there. There's a test fit with my nut, and that's good. This is a nylock nut, but it doesn't have to be. It's just what I had that was the right size. I'm not even putting it on deep enough to engage the nylon ring, so don't worry about that. Put a little copper washer on there because that grips nice and tight on rough casting material in my experience. And I'll get the crank pin holes aligned with a gauge pin while I tighten that, just in case I need to slide a pin in there as a drive dog later, but I'm going to try this without the drive pin just to see. It'll be nicer if I don't have to use it. And it spins up nice with the center in there, nothing vibrating, so that's looking good. As long as I don't ever touch this mandrel's position in the chuck, it will stay concentric because we turned it down in the 3-jaw, and as long as we don't re-chuck it or shift it at all in the jaws, then it'll stay concentric. I started by cutting down the OD of the 2 discs, and once again, I'm choosing setups here that have me machining both discs at once for each operation so that I guarantee that the 2 discs are as identical as I can get them when they're done. One thing that's neat about machining castings is that when you start out, they always look like they have lots of runout in them, even if they're actually running true. But then the more and more surfaces that you machine, the better and better looking they get, which is pretty cool. So after that, I can machine the front face here of this one. And this is very satisfying at first because I'm machining that outer rim there, but then once you get past that, you're machining a whole lot of air, but you have to do it. You have to treat the entire face as if it's a solid face being machined, because you got to catch the counterweight and the little boss around the crank pin all the way down to the hub, or else it's not going to look right. So this part is pretty tedious. It feels like nothing's happening, but you got to just let it run. And then while I'm here, I can also sneak in there and get the OD of the crank center boss there. Get that all cleaned up. I can't reach the front face of that boss yet, so I'll have to do that later. But I can get every other surface in this setup, so I feel pretty good about that. Once that first one is done, then I just pull that out of there, loosen that nut, flip it around, and do the other disc the same way. And we finish up by chamfering everything because chamfers are what separate us from the animals. Excellent progress so far. I'm very happy with where those discs are at. And I stopped and thought a long time before loosening the chuck jaws here. Make sure there's nothing else I need this mandrel for, because once I loosen those jaws, the mandrel is ruined forever. But thanks, little mandrel buddy. You did great. And I'll just put the discs back in the 3-jaw chuck with the reverse jaws on there, some copper shims to protect the finished surfaces, and I'll just tap that flush against the jaws and face that one last surface that I couldn't reach. There's going to be some run out in this disc because I'm gripping it with the 3-jaw, but for facing it doesn't matter as long as you get the surface reasonably parallel to the back. Chamfer because not animals, and bring them both to that point, and now we're ready for the crankshaft. Here I have a catch. This is the material they supply, and it's just long enough for the 2 stub shafts that they expect you to make. But I need something a little longer because I'm going to do it as one piece and cut out the center later. So I bought this material here which is the slight bit longer that I need. And this is actually 1144 stress proof. It's a little bit nicer steel than what's in the kit. Stress proof is cold rolled steel that's been normalized, so it doesn't tend to warp after you machine it, which is a nice feature in a crankshaft. And it should be very, very strong as well. I ordered it slightly oversized so that I can turn it down and get it really nice and straight. I faced both ends, put centers in them, and then faced it down to the exact length that I need, and then I'm turning it between centers for all subsequent operations. This is my first time working with stress proof, actually. I've heard good things about it. It's supposed to machine very well, and I'm inclined to agree. It does indeed. As I get close to dimension here, I'm just checking for taper to make sure that my tailstock doesn't need adjusting, as it often does, and everything looks good. So I flipped it around and turned down that final end where the drive dog was sitting to the same diameter. Generally, just turning down to the same number on the hand wheel gets you close enough. If you did it right, that last tool mark should disappear, and it does, so looking good. I also put a very generous chamfer on the ends because chamfered ends on crankshafts always look nice. You're going to see the ends of the crankshaft forever on the engine, so it's worth the time to make those look nice. Alright, first test fit here. If I did my job right, these discs should just barely slide over this crankshaft. They should be kind of difficult to slide on there, which they are. That's good. Everything has to be really, really straight or they won't move and they get stuck easily, which is a sign that the fit is very close. And that is necessary for this idea to work. If these are the least bit loose on there, then the whole system is not going to be tight enough when it's done. Alright, feeling pretty good that this might actually work, so I'm going to go on and make the crank pin next. So I'm using this shorter piece of stock that the kit gives you for this purpose. So I just faced and center punched the end, got the tail support in there, and then I'm just marking all the diameter changes. This is a pretty straightforward part. The only trick is you really want to make it all in one setup so that you maintain concentricity on all the features here. It's a really important thing for a connecting rod journal like this. So I'm turning down the first shoulder on the end there. This one is extra long because I want to cut the center out of it when I'm done. I don't want that center to be in the final part. So there's extra length at that end. I'm taking my time here because this dimension is very critical as well. Remember, the ends of this pin have to slide into the crank discs, but again, just barely slide in. It has to be a very close sliding fit. So I'm happy with that. I think that's going to work. Once again, it's like a 3/10 sliding fit, like an RC2. So really taking my time to hit that. And that's it for the easy features. The rest of the features on this thing have to be done all with the grooving tool in order to, again, maintain one setup here. So the basic process that I'm using is I just go in on the first pass until the dimension is just a couple thou larger than final, and then I go into the final depth and then pan across with the grooving tool to finish the surface. And that method actually works really well in my experience. You can turn sideways with a grooving tool as long as it's a light cut. And then I'm using gauge blocks to make sure that that width is correct as well. That's also very important for a crankshaft journal. And then I can do the other end, the other little pin that goes into the other crank disc. Again, it has to be a grooving operation because I can't access that end. And here I can't do a test fit, so I'm just trusting the dimension that I measured on the first pin and trying to hit it as close as I can on the second pin. And I'll break all those edges with a file. And I can part it off. Parting it off a little bit long here so that I can face it down to the exact length. And Yahtzee. Then I switched out to the collet chuck because that'll allow me to grip the outermost features there easily, and I can face off the ends there. So the short end I just face off to exact length, and then I'm also just kissing the inside shoulder there of that journal to make sure that, combined with the chamfer on the inside of the disc, that the discs are going to sit extremely square down onto those shoulders. That's really important as well for strength. There can't be any gap there. That looks good. The other end is quite a bit too long, so I don't want to face it all the way down, so I just part off a big chunk there where the center was, and then I face that down to final length. Okay, big moment. I put it all together. Let's see how my run out is. Let's see if this whole strategy is going to work. So on the main discs there, I've got, I would say, less than a thou on both of those, so that's encouraging. And then on the faces of the disc, I've got a little more, maybe 2 or 3 thou, but that's okay. Spinning it up, it certainly looks smooth, so I'm feeling good about that. I think this idea might actually work. So it's going to remain assembled like that for as long as possible to make sure that it stays concentric. A quick trip over to the mill now for the crankshaft. I centered it up with the edge finder, and I need to mill a keyway down both ends of the shaft. Now the first one I milled to the drawing, and then I looked at it and I thought, gosh, that's awfully long. I wonder if that's right. But I went ahead and used an end stop to flip the bar around so that I didn't have to re-measure or indicate anything. And then I milled the other side. Now, I milled the other key slot shorter because the way it was on the drawing, one of the keyways would be running inside the valve eccentric, which I didn't love. So I made that one shorter, as you can see there. That's the full size width there. So I thought, okay, problem solved. I'm smarter than the drawing, right? Well, then I go ahead and mock it up here so that I can get the position correct laterally for all these features on the crank. You can see how I've got enough room there now that the main bearing will be on plane shaft, as will the eccentric. So that's all looking good. Feeling pretty pleased with myself for that. But then I flipped it around and realized I'm not so smart. When I was cutting that first keyway, I had a little voice in my head saying, you know, I should check the dimension on that one too, see where the main bearing is going to land. And I didn't. I ignored that voice. And well, the keyway is going to run in the main bearing, as you can see there. So I was not a huge fan of that. Now, I actually wrote to PM Research about this because I felt like that was a mistake in the drawing. They said it isn't. That's how the engine is designed. I consulted with my Patreon supporters, and my patrons actually sent me examples of other engines that do that, so apparently it's not uncommon, but I still didn't love it. So I was able to recover this by finding a different lateral position for the discs where both main bearings are still going to land clear of the keyway. I had made the one keyway short enough that if I just move the crankshaft a little off center, I can get away with that. So I feel better about that. So happy with all that, it's time to pin things together. I pulled the crank pin out and measured the exact length there between the shoulders because that's the distance that I need between the crank discs all the way around. So I was able to clamp the pin in place, then make a gauge block stack the same thickness and clamp it on the far side to make sure everything stays parallel here between the two crank discs. And just double check here with a micrometer in a couple of places around the two discs. Everything looks to be parallel, so feeling pretty good about that. So now this whole monstrosity goes over to the mill. The shaft is held in a collet block, but I put a bolt in a 1-2-3 block there to act as a little machinist jack underneath one of my cant twist clamps there. Then I can clamp that from above, and what that's doing is keeping the crank discs from rotating on the shaft while I do this drilling. This doesn't have to be very secure. There's not a lot of forces there, but just a little bit of safety. So then I use the edge finder to center up on the crank pin there. And I'm also centering up on each crank disc using two different datums in the DRO to hold those. And then I can center drill, and ream each of these locations for the pins that are going to hold everything together. I'm drilling deep enough to go through the outer cast iron web through the entire steel pin and then a ways into the cast iron on the far side of the pin. So it's fully cross-pinned for maximum strength. The pins themselves are 01 tool steel, and they're going to be a very, very close fit into these holes, which is why I'm reaming them. So the pins are definitely stronger than everything around them. They shouldn't be a weak point here at all. A little test fit with those pins, and that looks really good. Now, in hindsight, I think taper pins would have been a better choice here. They would have held tighter and really guaranteed alignment of everything, but I'm not set up for taper pins. I don't have the fancy reamers and stuff that you need for that, so this is what I did, but taper pins probably would be better. Then I did the two bosses on the crankshaft the same way to pin those in place. With everything dry fitted in final position here, I can pull this setup apart now. Now it's time to Loctite everything in and make it permanent. So I'm using some acetone to clean up all the surfaces here, make sure that the Loctite has lots of clean surface to work with. Now my plan was to slide these crank discs out and put Loctite on the shafts there and then slide the discs back in. However, I didn't anticipate that the drilling created burrs that locked all these parts together, so I could not get them apart. I didn't want to force everything too hard and start mangling up parts here. So I decided to leave them together as is and Loctite the pins in place, because the pins are doing 90% of the holding anyway. I was going to put Loctite in there for some insurance, but honestly it shouldn't be necessary. But just in case, I'm using Loctite 603 here, which is actually the low viscosity version of Loctite 680. And this stuff will actually wick into joints very well if there's any kind of clearance in there, which there shouldn't be anyway, but if there's any area there where I do have clearance, this stuff is going to wick its way right down in there. And you can actually see it happening here. So give that a few minutes to seep down in there and then wipe up the excess, and I think that'll definitely help. Again, it shouldn't be necessary anyway, but it can't hurt. And I just filed down the excess length of pins there, starting first with a coarse file and then finishing up with a smoother file. The outer discs were easy. The inner ones were a little trickier, and I left those ones a little long. So I started with a fret saw using a bit of shim stock there as a shield to protect the finished work. Then to finish those, I have a safe edge file here. That's a file where I've ground the teeth off one side of it. And I've also got a little piece of shim stock here to act as a protective shield for a little extra insurance. And then I can once again file those pins down all the way. And once I got close to final, I just got rid of the shim stock because it really wasn't helping very much. The safe edge file is really all you need. So I just filed the inner one smooth. And now final run-out check once again here on the lathe, just before I cut the center section out of it to make it into an actual crankshaft. And it's running very, very true there so far. Very pleased with that. So the drilling and pinning and all that has not affected the run-out here at all. Everything's still running true. So far, my little scheme of using the center shaft to keep everything in line is working. And, well, while I have it set up here, I might as well polish these up. Got a little carried away. That polish is nicer than necessary, but it did make those pins virtually disappear. You can still see them if you look for them, but they're basically gone, so I'm pretty pleased with that. But it's not a crankshaft. Right now, it's just a finger-mangling death machine. So no more procrastinating. It's time to cut that center section out. Got shim stock taped up against the inside of the crank disc there to protect it from the bandsaw blade. I run the blade through one side, move it over to the other. Not a crankshaft, not a crankshaft, not a crankshaft, crankshaft. Well, that was terrifying, but now the real moment of truth. Has something sprung or shifted from that? Is it still running true? The answer is, no, it is not. Now, I had a moment of panic here, but stay with me. So it looks like it's running out quite a bit, and I was pretty concerned about this. So I started taking some measurements. The measurements were very consistently telling me the same story everywhere I checked, and that's that the crankshaft was folding inward away from the pin. And that makes perfect sense because that's where the strength is. And then I realized what the problem was. My muscle memory had jammed the tailstock in there quite firmly, and the tailstock was having no trouble compressing that assembly, and that was causing the run out. So instead I clamped it up in the collet chuck holding one shaft and then very lightly supported the other end with the tailstock, and the run out vanished. So that's all it was. It's just a little too aggressive with the tailstock. It's not a very rigid structure end to end, but those are not forces that a crankshaft ever sees, so it doesn't need to be rigid that way. Now I just need to get rid of those remaining stub shafts there in the center, so I just clamped one disc up in the vise, and I have a comically long end mill here that was a donation from a viewer. Happens to be a ball nose, but that doesn't matter because I'm just side milling with it. And this was just the ticket for reaching down in there and shaving down those little stubs. I got all the way down to just short of touching the crank discs, but I didn't want to risk messing up the crank discs, so I finished that up with a file. And I'm not going to lie, this filing was no fun at all. The position of it was very awkward, and it was a lot of work. But, you know, one must suffer for one's art. And there is the final crankshaft. I'm very pleased with how that turned out, I have to say. It was a lot of fun to make. I think that my wacky approach for building this worked. I don't know if it was necessary. Maybe it would have been just fine to make the parts and press them together the way the drawing says to do. I don't know, but I felt better about doing it this way. I felt that my odds of ending up with something concentric were better, and time will tell if my approach of Loctite and pinning all these parts together is going to be strong enough. I feel good that it is, but we won't know until it makes horsepower. That's it for this episode. Thank you for sticking with me through this journey. Thank you especially to my patrons who make all this possible, and I will see you next time.